Hello, my name is Micaela Jurado, and today we're going to talk Lab 3 magnetic fields of a bar magnet. So this is the outline of our experiment. The purpose of this experiment was to measure the distance dependence of a small cylindrical bar magnet and compare the results to the distance dependence determined by on-axis and off-axis derivations. We will also do these derivations based on the Biot-Savart law for electromagnetism. These are our results that I will discuss in a little bit. So these are the key concepts we're going to use. So we're going to use Biot-Savart's law, which relates the magnetic field at a point to a tiny current element, the magnetic field of a dipole, and the distance dependence formula, which we will all discuss in a little bit and discuss the formulas that we derive from these. And we also know that the Earth produces a magnetic field, so we must take this in mind to adjust the bar magnet. And the distance effect on magnetic fields is that the further away from the source, the smaller the magnetic field. And also the closer to the source, the larger the magnetic field. So these are the formulas based of the concepts. For Biot-Savart law, we're going to use this formula, and with our on-axis derivation, we're going to use this formula, which R is the distance between the sensor and the magnet. And for magnetic dipole equation, we're going to use this formula, which is the off-axis derivation, and the bar magnitude is this formula. And we can linearize this formula, and it was going to give us this formula, which K is the combination of constants and parameters, and R is the distance. So this is our experiment walkthrough. We will first orient the phone to make the magnetometer orthogonal to Earth's magnetic field, find the location of the magnetometer chip on the phone, and measure the distance between the magnetometer and the on and off for the on and off axis. So the magnetometer is the X over here, and we're going to measure the distance between the magnetometer and for the on and off axis. So our observation is when the magnetometer is far away from the magnet and measures a near zero magnetic field in the X duration. But as the magnetometer moves closer to the magnet, the measured X component of the magnetic field increases. So this is our experimental data and calculations on axis. We get that our equation of the line is this here, and we get that our n is -3, and we're gonna plug this y-intercept into this formula, which is gonna give us mu. When we get k, we plug this one here, and it's gonna give us mu, which is 1.579 amps times meter squared. Oh, and also this is the graph we got, and these are all of our data points. So measurements off axis, these are all our data points, and we average them to get d/per by Earth, and then bxt and all of the other points. So we get that our experimental B is 0.9766, 0.00049, 0. And then this is our coding computational model. We see that over here, this is creating the magnet at origin. This is to create a function for the magnetic field. This is to visualize the magnetic field on axis and perpendicular to the axis. And these are 4 perpendicular arrows to the axis. And also we have these arrows that are to represent the magnetic field on axis. So we get that this result, and we see that our dipole perpendicular is here, or B, which is going to give us 3.59 times 10 to the -6 and 1.79 times 10 to the -5. Our orange arrow is on axis, or it's really tiny, but our purple arrow is at 45 degrees, and our green arrow is at off axis. And then this is our lab discussion. It is, what if you hadn't orientated your experiment to compensate for the magnetic north? So if I hadn't orientated my experiment to compensate for the magnetic north, the resultant vector would have increased, since we have to add Earth's magnetic field instead of the bar magnet's magnetic field alone. Also, the results would have been less accurate, since it's regarding for distance dependency. And the other question is, what if you were to stick two identical magnets together end to end and run the experiment again? So if I would stick two identical magnets together, the magnetic field would have been much stronger, and this would make the distances between the magnet and the magnetometer smaller. Also, the direction of the measured magnetic field would have not changed. That'll be all for today. Thank you so much.